or disintegration. Okay. Okay, so I have a nuclei is decaying to B, and B is further decaying to C, and we have assumed that C is stable, right? And there's a decay constant lambda 1 and lambda 2, right? Initially, you have a at t equals to 0, it was like n naught number of nuclei, number of B nuclei 0, C nuclei 0, and at time t equals to t, it was n1, n2, n3, right? And we have derived that number of A nuclei present at a time t, that was n naught e to the power minus lambda t, and number of B nuclei present after time t, it was n naught lambda 1 by lambda 2 minus lambda 1, and then you will have e to the power minus lambda 1 minus lambda 2. Now a C nuclei, that was n3 t after time t, that C nuclei was like n naught, then you will have 1 minus lambda 2 e to the power minus lambda 1 t, then you will have lambda 2 minus lambda 1, and then you will have lambda 1 lambda 2 minus lambda 1 e to the power minus lambda 2 t, right? And we have also plotted that number of population on nuclei as a function of time, nt. That behavior was like, you have a this is the nature of n1, the nature of n2 was like this, and the nature of n3 is like this. And I ask you to calculate at what time, at time t equals to t dash, that population of n2 is maximum. So you have to find that time t dash that I ask you to do. So that I can calculate from here. You see, you have a n2 as a function of time. This number of B nuclei as a function of time. So I can calculate that maxima and minima. It's a function of time. So how will calculate that maxima? At what time that n2 will be maxima? ना कोई function में function का, you have a function, how will calculate the maxima or minima? Just you have to differentiate with respect to variable, right? Yes or no?
Yes, sir.
Yes.
So
Yes, sir.
what you have to do, you have to differentiate this n2 t with respect to time, and you have to substitute t equals to t dash, because at t dash that population is maxima. So differentiation of this function with respect to time at t dash, that will be 0. Because you know at t dash that population is maximum. So obviously at this point the differentiation will be 0. Right? At this point you can see differentiation is nothing but slope. At this point there is a 0 slope, right? So if you substitute now, if you differentiate this function with respect to time, and if you keep t as t dash, then what will happen? This term, this factor is constant. Nothing will happen with this. Nothing will happen with this. Inside bracket, it will become what? इसका differentiate करोगे, and in case of t, if you place t dash, it will become minus lambda 1 e to the power minus lambda 1 t dash, right? And the second part, if you differentiate this factor with respect to time, you will have minus lambda 2, and you already have minus here. So that will make lambda 2 e to the power minus lambda 2 T dash, and that will be 0 because at T dash is the maximum. Now you have a two factor A into B. A into B will be 0 if either this A is 0 or B is 0. But this factor is not 0, right? Because all are non-zero quantity here. So this factor is not 0. So obviously this factor will be 0. Now if we keep this factor is 0, what will happen? If you keep this factor is 0, and basically I'll get minus lambda on e to the power minus lambda on T dash plus lambda 2 e to the power minus lambda 2 T dash, that will be 0. It means lambda on e to the power minus lambda on T dash, that will be lambda 2 e to the power minus lambda 2 T dash. Right? Now if you rearrange it, you will have lambda on by lambda 2. That will be कितना हो जाएगी? Tell me.
E की power lambda 1 minus lambda 2t
E to the power lambda 1 minus lambda 2
into t.
T dash, right?
Yes, sir.
Now if you take natural log both sides, what will happen? You will have ln lambda 1 by lambda 2, and that will be exactly equals to lambda 1 minus lambda 2 T dash. Right? Is this clear what I'm saying?
Yes, sir.
Okay. Now it means that T dash कितना आ जाएगी यहाँ से? T dash will be 1 by lambda 1 minus lambda 2 ln lambda 1 by lambda 2. So the expression of T dash. So this T dash, the time at which the intermediate nuclei means B nuclei will be maximum, that depends upon decay constant lambda 1 and lambda 2. Okay. Is this clear? Now there is a radioactive equilibrium. A radioactive equilibrium. Okay, so first equilibrium is basically radioactive equilibrium. Na? Okay. So radioactive equilibrium means you understood. You have A decaying to B, decaying to C with decay constant lambda 1, lambda 2, and at t equals to 0, it was n0, n0, 0, 0. At t equals to t, it was n on, n2, and n3. Right? So there are basically two types of radioactive equilibrium. One is known as secular equilibrium. One is known as secular equilibrium. Secular equilibrium. Okay. One is called secular equilibrium. So what is secular equilibrium? And this secular equilibrium can be achieved. You have a decay constant lambda 1 and lambda 2, right? So this secular equilibrium can be achieved when lambda 2 is much greater than lambda 2 is much greater than lambda 1. Then this equilibrium can be achieved. So secular equilibrium का मतलब ये है कि जो intermediate nuclei, the intermediate nuclei is actually not changing with time. So equilibrium, there's an equilibrium in intermediate nuclei. तो यहाँ पे intermediate nuclei कौन है?
E sir.
एग्जैक्टली बी। सपोज अगर यहाँ पे अगर सी स्टॉप ना होकर सी फर्दर डीके हो रही है, इसका मतलब क्या है, इंटरमीडिएट न्यूक्लियर विल बी बी एंड
B
सी।
and C.
ओके, सो सेकुलर इक्विलिब्रियम का मतलब है दैट इंटरमीडिएट न्यूक्लियर विल नॉट चेंज विद टाइम। देयर इज ए इक्विलिब्रियम state of, or equilibrium, I mean this b nuclei will not change with time। इसका मतलब क्या है, b nuclei will not change with time, इसका मतलब क्या हुआ है, the production rate is same as decay rate, then there will be no change in the nuclear number of nuclei of b nuclei, right, है ना? Did you get what I'm trying to say? That this equilibrium का मतलब क्या है कि जो intermediate nuclei that will not change with time, ठीक है ना, that will not change with time। इसका मतलब क्या है, सपोज मान लो इसके पास कुछ 10⁻n न्यूक्लियाई है ना, इसमें से डीके भी हो रही है ना, इज डिकेइंग टू सी with some values like suppose some n decay per second, है ना, यहाँ से प्रोडक्शन भी हो रहा है ए से बी में। तो जब प्रोडक्शन रेट और डीके रेट बराबर हो गया, सपोज मान लो प्रोडक्शन रेट आपका 5 न्यूक्लियाई पर सेकेंड और डीके रेट भी 5 न्यूक्लियाई पर सेकेंड है, तो जो बी न्यूक्लियाई है दैट विल नॉट चेंज विद टाइम, राइट? आर यू गेटिंग व्हाट आई एम सेइंग?
Yes sir.
So that secular equilibrium is the equilibrium in which intermediate nuclei will not change with time। इसका मतलब क्या है, the rate of decay of intermediate nuclei will be same as the production rate of it, and that is only be possible when lambda 2 is much greater than lambda 1। We'll prove that। But if you under secular equilibrium, can I say that dn2 by dt, dn2 by dt का एक्सप्रेशन क्या था, that rate of change of b nuclei was like you have a lambda 1 n1, that was production rate, and there's a decay rate lambda 2 n2। So under secular equilibrium, this dn2 by dt, that is 0। Total rate of change of b nuclei, this is a production rate, this is a decay rate, so this is the total rate of change of b nuclei। Under secular equilibrium, there is no change of b nuclei, it means it will be 0। So under secular equilibrium, lambda 1 n1 equals to lambda 2 n2, है ना, lambda 2 n2। अगर सपोज मान लो c फर्दर डीके होके d में जा रहा है विथ lambda 3 डीके कांस्टेंट, देन अंडर सेकुलर इक्विलिब्रियम क्या हो जाएगी, lambda 1 equals to lambda 1 n1 equals to lambda 2 n2 equals to lambda 3 n3 and so on। ठीक है, tell me if you have any doubt। नो, हाँ ना बोल दिया करो, डाउट है?
Yes sir. Clear है.
क्लियर ना, ओके। So now you see you have a expression for n2, right? If you remember, you have an expression for n2, it was like you have a n2t, and that was like n naught lambda on divided by lambda 2 minus lambda 1 e the power minus lambda 1 t, and then we'll have minus lambda 2 t। ठीक है ना? अब सेकुलर इक्विलिब्रियम का कंडीशन क्या है कि this lambda 1 n1 should be equals to lambda 2 n2 and so on if there is process further going on c2d d2e so on। अब इस एक्सप्रेशन में देखो, अगर lambda 2 is greater than much greater than lambda 1 है, so I can ignore this term। It means lambda 2 is lambda 2 is having very high value and you have exponential decay, so this lambda is much greater than lambda 1, lambda 2 is having very high value, so I can ignore this term। I can ignore this term, or I can write that this term tends to 0, and also here this lambda 1 will be ignorable. Lambda 2 minus lambda 1, lambda 2 is much greater than lambda 1, this will be ignorable. So I can ignore that. If I do, then I'll get n naught lambda on e the power minus lambda on t, and then we'll have lambda 2. And if I bring that n lambda 2 on the left hand side, you will have n2 lambda 2, and that will be, now if you combine n naught with this e the power minus lambda on t, then how much I'll get? If you remember, that was nothing but n on, right? That is nothing but n on. So you'll get n on and you have lambda on. You can write that. So I can see this is a condition for secular equilibrium, that n2 lambda 2 equals to n on lambda 1 and equals to n3 lambda 3, so on. That can only be possible when that intermediate nuclei is having much greater than a greater decay constant value as compared to parent. So you have a condition like you have a lambda 2 greater than much greater than lambda 1, and there's a inverse relationship between lambda and t half, right? So basically I can write, we'll have a on by half life of b nuclei means 2, right, is greater than much greater than 1 by half life of a nuclei, that is noted as 1. It means the half life of a nuclei noted by 1 is much greater than half life of b nuclei. Then in that condition I'll get secular equilibrium. So secular equilibrium means there's no change of intermediate nuclei with respect to time. Tell me if you have any doubt. No? Haji?
Yes, sir, clear.
And there's another equilibrium that is known as transient equilibrium. Transient equilibrium. So transient equilibrium doesn't mean that intermediate nuclei is having constant number, or it doesn't mean there's no change in intermediate nuclei with time. But transient equilibrium का मतलब ये है कि n2 by n1, this ratio, that will be constant. And similarly n3 by n2, that will also be constant. And so on, n4 by n3, that will also be constant if that process is still going on. And this transient equilibrium will be possible when you have, lambda 2 is greater than lambda 1. Lambda 2 is greater than lambda 1. है ना? So secular equilibrium के लिए condition क्या थे? Lambda 2 was much greater than lambda 1. But transient के लिए lambda 2 is greater than lambda 1, and this equilibrium is not achievable initially. When that process is going on, after long time, this transient equilibrium can be achieved. but at the beginning or at small t, will not get this transient equilibrium. When the process is going on after long time, when t is much greater, I mean having very high value, like 2000 years and so on, then I'll get this transient equilibrium. Sorry, no, not 2000 years actually. It's like your 200 or 300 years. So the initially will not get this transient equilibrium condition. However, after a long time, I'll get this condition, transient equilibrium. And under transient equilibrium, that ratio of B nuclei, number of B nuclei to that of A nuclei, that will be constant. Number of C nuclei to that of number of B nuclei, that will be constant. And so on, if that process is still going on C to D and D to E and so on. Now, again, I'll start with that N2 as a function of time. And it was like you have N naught lambda 1 divided by lambda 2 minus lambda 1. And then you'll have e to the power minus lambda 1 t minus e to the power minus lambda 2 t. Now we have a lambda 2 is greater than lambda 1, and if t is large, then this term will be firstly vanished. Lambda exponential minus lambda 2 t will be firstly vanished. So for last t value, I can ignore this term. And I'll get n naught lambda 1 divided by lambda 2 minus lambda 1 e to the power minus lambda 1 t. Because these terms you have equated with 0, and that will be possible at large t. And you have this term you ignore because lambda 2 is actually greater than lambda 1. And if you see that n naught with exponential minus lambda 1 t, that will actually provide you n1. So you basically get n1 lambda 1 divided by lambda 2 minus lambda 1. It means n2 by n1, that number ratio of B nuclei to that of A nuclei, and that will be lambda 1 by lambda 2 minus lambda 1. And similarly, if you calculate, you will get n3 by n2. कितना आ जाएगी? जरा लॉजिक लगाओ. कितना आ जाएगी?
Lambda 2 by lambda 2 upon lambda 3 minus lambda 2.
But where is lambda 3 here? जी, where is lambda 3? That n3 by n2 that you can calculate if you have, suppose you have A is decaying to B, and B is decaying to C, and C is decaying to D. C is decaying to D, and with decay constant lambda 1, lambda 2, lambda 3. Then I can say that lambda n3 by n2, that will be lambda 2 by lambda 3 minus lambda 2, and so on. Okay.
सर जो हमने ऊपर स्टेप किया था जिसमें हम e रेस्ट टू पावर माइनस लैम्डा 2 t को 0 कर रहे हैं, तो सर जो e रेस्ट टू पावर माइनस लैम्डा 1 t है उसमें भी तो t बहुत लार्ज है, तो उसको 0 नहीं कर सकते?
नहीं, उससे पहले तो उससे पहले टी में मतलब टाइम आप बढ़ा रहे हो, है ना, यू आर इंक्रीजिंग टाइम.
यस सर.
हाँ, लैम्डा 2 इज ग्रेटर देन लैम्डा 1. तो आप बताओ पहले कौन वैनिश हो जाएगा?
तो
जिस
सर
टाइम
लैम्डा 2 t वाला.
हाँ, लैम्डा 2 जब वैनिश हो गया उसी कंडीशन को बोला जा रहा है ट्रांजिएंट कंडीशन.
ओके सर, थैंक यू सर.
ठीक है. Well, so now let us solve few problems. You have a problem number 1. You have A nuclei decaying to B, and B is decaying to C, which C is stable. And there's a decay constant lambda 1 and lambda 2. At t equals to 0, the A nuclei is N naught, B is 0, and C is 0. At t equals to t, it becomes N1, becomes N2, and C becomes N3. Okay. You have to calculate that number of C nuclei, and time is given. This time, at time t equals to t, N1, N2, N3. N3 is the C nuclei, N2 B nuclei, N1 N nuclei. So if you calculate that population of C nuclei, a time given है, that is much smaller than 1 by lambda 1, as well as t is much smaller than 1 by lambda 2. At this time, you have to calculate that population. कर लोगे? Yes, no? So this is a population of C nuclei, right? At time t, and know that expression. You remember that expression was N3t, and that was like you have N naught, and then on minus lambda 2 by lambda 2 minus lambda 1 e the power minus lambda 1 t, and then we'll have second term, third term, that is lambda 1 divided by lambda 2 minus lambda 1 e the power minus lambda 2. Right? And this t much smaller than 1 by lambda 1. इसका मतलब क्या हुआ कि t lambda 1, t lambda 1, that is much smaller than 1. And similarly, t lambda 2, that is also much smaller than 1. So much smaller than 1. So when that exponent power is small, very small values, then I can expand, and I'll take only up to a quadratic term, because when you have this number, power is so small, I'll expand, but I'll ignore that higher order term, right? जब कोई quantity x से छोटी होती है ना, and if you are making square and cube so on, that number will be insignificant. So what I'll do, I'll expand and I'll take only up to quadratic term, and I'll ignore all the higher order term because of this condition. Well, so if you do that, you'll have N3t, and that will be N naught first term. Now lambda 2 by lambda 2 minus lambda 1. Now I'll expand that. So first term will be on, second term will be minus lambda 1 t, and third term will be lambda 1 square t square by factorial 2. This is not 21, factorial 2. And similarly, I'll expand this also. You'll have lambda 1 divided by lambda 2 minus lambda 1. And if I expand on minus lambda 2 t plus lambda 2 square t square by factorial 2. I can write, and this kind of approximation you have done when we have calculated that heat capacity of solid, right? Okay. And then n naught. Now see, this you have this term, you have this term and this term. If you merge together, this term on multiplied with this factor, on multiplied with this factor. If you merge these two terms together, what will happen? We'll have minus lambda 2 minus lambda 1 divided by lambda 2 minus lambda 1, right? And you see, you have a second term, that is minus minus plus lambda 2 lambda 1 t by lambda 2 minus lambda 1, right? और यहाँ पे देखो, you have here you have a plus term, you have a minus term in this term, है ना? यहाँ पे देखो आपका क्या मिल जाएगी, minus lambda 2 lambda 1 t divided by lambda 2 minus lambda 1. So these two term actually will be cancelled, right? If you combine with this factor, ठीक है ना? हाँ ना बोल दिया करो.
Yes, sir.
Yes, sir.
And then you have a last term. अब last term में देखो क्या है, you have a t square common, right? You have a t square common, lambda 2 lambda 1 and 2 common. So I can see from this term I'll have common factor, that will be t square by 2 lambda 2 minus lambda 1, as well as you will have common, that will be lambda 1 lambda 2, and I'll get lambda 2 minus lambda 1. तो देखो ये कैंसिल हो जाएगी और इसमें मिलेगी क्या, एक मिलेगी, जो एक के साथ एक कैंसिल हो जाएगी, और यहाँ पे क्या हो जाएगी आपका lambda 2 minus lambda 1 will be cancelled. At the end you will have n naught lambda 1 lambda 2 t square by 2. So this will be the population of t nuclei when t lambda 1 and t lambda 2 both much smaller than 1. Okay, is this clear to all?
Yes, sir.
Okay, second problem. Again you have a chain of decay, A decaying to B and B decaying to C, and stable. C is stable. Okay, and their decay constant are given as, okay, half-life given, half-life of A nuclei is given, half-life of A nuclei is given as 10 hours, and half-life of B nuclei is given as 1.3 hours. So to calculate time at which B nuclei will be maximum, I have to calculate the time at which B nuclei will be maximum. So I know that relation, right? We know that lambda is related to 0.693 by t half, right? And I know that expression for T dash also, at which intermediate nuclei max will be maximum. That is like you have a lambda 1 by lambda 1 minus lambda 2 ln lambda 1 by lambda 2. So it means if I calculate lambda 1 is nothing but 0.693 divided by half-life of a nuclei, and that is given. Half-life of A is nothing but 10 hours, right? So it will be 0.0693 or inverse. And similarly, I can calculate lambda 2 as well. If I do, lambda 2 will be how much? It will be like 0.693 and divide by 1.3. So if you calculate, if you do that, I have done, you'll get 0.53 or inverse. I have calculated lambda 2 and lambda 1, right? So now I can calculate that time at which B nuclei will be maximum. So we'll have a T dash, and that is like 1 by lambda 1 minus lambda 2 ln lambda 1 by lambda 2. Okay, so I'll substitute that values. So lambda 1 was how much? Kitna the? Lambda 1?
0.0693.
0.0693. And then we'll have lambda 2, that is 0.53, right? And then we'll have a ln 0.0693 divided by 0.53. Calculate, you'll get T dash, that will be 4.428 hours. ठीक है ना? Is this clear, student, to all?
Yes, sir.
Then why you have not done that homework? सारे clear हो रहे हैं, then why you are not doing homework? Tell me, what happened? Okay. Then next problem. Next problem you have again. A is decaying to B. B is decaying to C. And C is stable. And the decay constant of A nuclei is 10, sorry, lambda. And for this, it is 10 lambda. Okay. At T equals to 0, there was only A nuclei present, N naught, and B and C nuclei were 0. And at T equals to T, this becomes N1, this becomes N2, and this becomes N3. So to calculate N2T divided by N1T, that you have to calculate. That you have to calculate. कर लोगे? Remember that this was the expression, right? N1 was like you have a N naught e to the power minus lambda 1 T. This is the expression, right? If you remember. And here lambda 1 will be how much? क्या होगी lambda 1?
lambda.
Exactly, it will be minus lambda t. And similarly, n to t कितना हो जाएगी ये? n naught lambda 1 कितना है? lambda है divide by lambda 2 minus lambda 1. Lambda 2 is how much? 10 minus 1, that is 9 lambda, and you will have exponential minus lambda on t. Minus lambda 1 means minus lambda t, and then you will have minus 10 lambda t. Let us take this is equation number 1 and this is equation number 2. Okay. Now if I divide equation 2 by 1, you can write this as a n on t also. If you divide equation 2 by 1, I'll get n2 t by n on t, and that will be कितना आ जाएगी ये? n naught by 9, right? This lambda will be cancelled. N naught by 9 divided by n naught minus lambda t, and then you'll have exponential minus lambda t minus exponential minus 10 lambda t. This n naught will be cancelled, and I can bring that exponential minus lambda 2 lambda t in numerator. If you do that, you will get 1 by 9 into this will be minus, sorry, this will be on minus कितना आ जाएगी? कितना आ जाएगी?
e to the power of minus 9 lambda t.
Exactly. It will be to the power of minus 9 lambda t. Okay. Tell me if you have any doubt.
No, sir.
Everyone? No doubt?
No, sir.
No, sir.
Well, next part. Okay. So I'll discuss a bit about that alpha decay, है ना? तो आज के बाद जो जैम वाले बच्चे हैं ना, स्टूडेंट्स हैं, उनका कोर्स खत्म हो जाएगा ना. I'll little bit discuss about that alpha decay, and that is all about that jam syllabus. From tomorrow, if someone interested, then he or she can join from jam batch. Otherwise, I'll continue for net students. So I'll discuss bit about first alpha decay, and that will be the end of jam course. Then I'll continue that net topic further. ये कॉमन टॉपिक थे आप लोगों का, ठीक है? Okay, so I'll discuss about that alpha decay. So alpha decay happens only when the parent nuclei is having large atomic number greater than 83 and mass number greater than 150. Then if the parent nuclei is having bigger size means large mass number and atomic number, and there's a condition when it says Z is having greater than 83 and mass number is greater than 150, then it can undergo alpha decay. I know what is alpha particle, right? Alpha is nothing but it contains 2 proton and 2 neutrons. And I can say that doubly ionized helium also. So in that process, if I write that equation, you have a parent nuclei ZA, and the Z is greater than 83, mass number greater than 150, and due to bigger size as a small binding energy per nucleon, so it is not stable, it will undergo alpha decay, right? We have discussed this in binding energy per nucleon curve also that time, right? So as a alpha decay, we'll have a daughter nuclei Y with atomic number Z minus 2, mass number A minus 4, and you'll have alpha particle. You'll have a alpha particle, right? And in this reaction, there's a production of energy, right? And that is known as Q alpha. Why I'm writing Q alpha? Because when there is this process is actually spontaneous process. In spontaneous process, there will be always release of energy. There is a Q is means release of energy. And why I'm writing alpha? Because this release of energy is in the form of kinetic energy of product. But why I'm writing Q alpha? Because most of the energy is releasing in the form of kinetic energy of alpha particle. ठीक है ना? सपोज मान लो यहाँ आपका सपोज मान लो 4.2 इलेक्ट्रॉन में MeV अगर एनर्जी इमिट हो रही है, सपोज मान लो Q alpha that is 4.2 MeV. So among this total energy, यहाँ से जो आपका kinetic in the form of kinetic energy of alpha particle, that energy contribution will be 4.18 and so on. ठीक है ना? तो जितना एनर्जी रिलीज हो रहा है, the energy is releasing in the form of kinetic energy of product. However, almost all energy is releasing in the form of kinetic energy of alpha particle. That's what I am using this symbol. है ना? तो जो एनर्जी रिलीज हो रही है, that is in the form of kinetic energy of product. But contribution जो है अल्फा पार्टिकल का ऑलमोस्ट सेम एज द क्यू वैल्यू है ना, इसका कंट्रीब्यूशन बहुत ही स्मॉल होती है. एंड द रीजन बिहाइंड दैट, किसका जो एनर्जी रिलीज हो रहा है दैट इज इन द फॉर्म ऑफ काइनेटिक एनर्जी ऑफ प्रोडक्ट. बट ये सारे एनर्जी इसी में रहता है अल्फा पार्टिकल में, इसमें नहीं होती है. क्यों? ऐसा क्यों है?
Sir, please repeat the question.
You understood what I have written Q alpha? इसका मतलब क्या है?
Because the mass of
Energy.
Y is very high.
सर आप प्लीज इसको रिपीट कर दो, काइनेटिक एनर्जी वाली चीज को, ये चीज समझ नहीं आई.
हाँ, तो अभी जब मैं क्वेश्चन पूछ रहा हूँ तब आपका मन में आ रही है. मैं कह रहा हूँ इस रिएक्शन, ये जो रिएक्शन है आपका क्या है? स्पॉन्टेनियस प्रोसेस, राइट? So there will be release of energy. Q alpha is meaning is that Q alpha का जो मतलब है release of energy है.
Yes, sir, in the form of product.
That will be in the form of kinetic energy. जो energy release हो रही है यहाँ, that is in the form of kinetic energy
Energy of alpha particle.
Alpha particle.
and daughter nuclei. But यहाँ सपोज मान लो जो एनर्जी रिलीज हो रही है that is 4.2. तो 4.2 में क्या है? That will be the sum of the kinetic energy of alpha particle and sum of the kinetic energy of daughter nucleus, that will be equals to 4.2. बट अल्फा लिखने का मतलब क्या है? इसका ये जो वैल्यू होते हैं that is almost close to the kinetic energy of alpha particle. I have given that example. यहाँ अगर Q alpha का वैल्यू समझ लो 4.2 मेगा इलेक्ट्रॉन वोल्ट है, at this time that alpha will get around, or kinetic energy of alpha particle will be around 4.8. You can understand now. जो एनर्जी रिलीज हो रही है, मैक्सिमम एनर्जी इज इन द फॉर्म ऑफ काइनेटिक एनर्जी ऑफ अल्फा पार्टिकल. द वेरी स्मॉल कंट्रीब्यूशन इज हियर ऑफ daughter nuclei. Someone gave that correct answer because that kinetic energy is nothing but or inversely proportional to mass of particle, right? You have a daughter nuclei having very large mass,
Higher mass.
and it's very small, right? So that's why you will get kinetic energy of this particle is high. Because kinetic energy जो है that is nothing but p square by 2m, right? दोनों के पास p सेम रहेगी. क्यों? क्योंकि यह this particle is decaying at rest. ये पार्टिकल रेस्ट पे डिके हो रहा है, So to preserve that momentum, mod of P should be equals to mod of Py should be equals to mod of P alpha. तो दोनों के पास जो momentum है that is same, but the mass of alpha particle is light as a heavy mass. As a result, the kinetic energy of this alpha particle will be very high, and it's almost close to Q value. That's why it is written that energy releasing in the form of kinetic energy of alpha particle. That's why I'm using that Q alpha. But there's a relation. That relation is really important for all aspirants. That kinetic energy of alpha particle is nothing but the mass number of daughter nuclei divided by mass number of parent nuclei in alpha decay, and you'll have a Q value, Q alpha. Every time you will get question from here. You'll have a every time. ठीक है, kinetic energy of alpha particle is related to mass number of daughter nuclei divided by mass number of parent nuclei into Q alpha. Q alpha क्या है? Q alpha क्या है? Total energy release.
Energy released.
Total energy released. Huh? Although this number, I mean, now here also you can understand that kinetic energy of alpha particle will be similar to Q alpha. Q क्योंकि जब आपका A, so it's almost ignorable, right? 4 is almost ignorable. When you have a number is large, nothing. 4 is nothing, right? So this number you will get close to unity, not exactly unity, but close to unity. That's why in notation it is used to write that kinetic energy alpha particle is almost equals to energy release. That energy almost same. But how will calculate that Q alpha? कोई reaction में क्या process है? Suppose you have a is decaying to B plus C. I am giving general expression, है ना? आपको इसमें Q निकालनी है, Q वैल्यू. ये क्या है? Q वैल्यू और एनर्जी रिलीज. कैसे निकालोगे? सपोज मान लो इस न्यूक्लियस का रेस्ट मास A है, इसका B है, सॉरी MB है और इसका MC है. तो इस रिएक्शन में जो एनर्जी रिलीज होती है that is known as Q value. Q का मतलब क्या है? Q value, and that will be nothing but mass of the reactant, sum of the mass of the reactant, or sum of the nuclear mass of the reactant minus sum of the nuclear mass of product. ठीक है, into C square. For alpha decay, what I'll write? I'll write the mass, nuclear mass of parent nuclei minus nuclear mass of daughter nuclei minus mass of alpha particle into C square, and that will be your Q alpha. Okay. So if they provide you that Q value, if they provide that Q value, and in alpha decay, you have A minus 4, you have a mass number of parent nuclei. If they provide you that Q value, or if they're not providing that Q value, but they're providing that mass, nuclear mass of parent, daughter, and alpha particle, you can calculate that Q value, and you can calculate the kinetic energy of emitted alpha particle in alpha decay. So in any decay, if they provide you the nuclear mass in alpha decay, especially if they provide you that nuclear mass of all parent, daughter, and alpha particle, you can calculate Q value and you can calculate the kinetic energy of emitted particle. Okay, so really important for all aspirants. Okay, so I think it should stop here. From tomorrow there will be only NET students. Okay, shall I stop?
Thank you, sir.
Thank you, sir.
Thank you, sir.